Hi, good morning. Can you hear me? Yeah, good. Thank you. Hi, Ancheng. I have made you the co-host. Good morning.
Okay, thank you.
Sure. So, yeah, please help me to admit students into the session and help me maintain the session. We are still have the number of people joining growing, so let's wait for a few minutes. And everyone, thank you very much for coming this early every time. If you have any questions, you can take the chance and either you can just speak up or you can type your questions in the chat box. Where is some? Okay. Let me see our chat. Okay. No questions so far? Choose session. Yeah, so let me take the opportunity to thank everyone for giving us feedback. They are really helpful. I'm really encouraged by your comments. I haven't enough time to address those comments one by one. I think I will maybe during the weekend or sometime next week and give you a more detailed feedback to the feedback. However, I have some rough feeling of the feedbacks. Mainly, there are two or three. Maybe the first one is everybody is, I mean, a lot of people who really give us suggestions is about to increase the amount of help we offer in terms of coding. Yeah, I admit that the software implementation is really an important part. So therefore, I think we will allocate more time in the online session to help you. And of course, it's important for you to everybody to understand that we offer plenty of consultation hours. Well, we have half an hour following this session. I will offer help here. And then followed by that, Ancheng will offer another hour. And from 5 to 6 p.m. Wednesday, Eastern Australian time, I will offer another hour following the other session. But the session was for students in 3 to 513, but the consultation hour is for everybody. And as well, we have a book-based consultation hour in Thursday. So you have a lot of opportunities to talk to us and get help. And also, it would be a good idea to when you are stuck somewhere, to make an explicit elaboration about the situation. Like, I try to implement what algorithm, and I'm stuck at the step of doing something. Well, the reason I'm stuck in because I don't know, the system just does not work, and it gives me no complaints or some complaints. So if the system gives you error messages, you can post the error message. So when you compile all the error this kind of information, you can post it to the Q&A discussion board, and hopefully someone or one of us can help. Okay. Well, still we have continuously people join the session. Okay, we will start soon, maybe in 3 minutes. In the meanwhile, let me have a look at the chat box. I got a question. Is this a new assignment? What do you mean by this? Today I will talk about an assignment. Yes, I will talk about an assignment. I will. There is a. I will talk about assignment 2 today. Oh, sorry, I haven't finished about the student feedback part. The other feedback is I think from the vast majority of people, the you like the style of this delivery, but a few of you think it would be more helpful if we have some summarized notes to maybe review for students to review. I think that is a very legitimate requirement. Therefore, you have the notebooks for every week, but those notebooks are not always discussed in class. So I summarize everything we discuss in class, which means I point out the emphasizes in the notebooks and compile them with the take-home points, and make a new notebook. And I made the new notebook available in the online materials here. So, no. So from now on, I will help you to make some notes in class. You do not need to preview these notes prior to the class. After the discussion, I will put a link here, and you can have a quick review. Yeah. Well, now it's nearly 10 minutes into the session. Let's start. Very welcome, everybody. Thank you very much for coming in this early hour into this difficult subject. So I'm really encouraged that we have this many people join. Good. Well, as usual, let's have a very quick review of what we are up now. In this subject, we have already gone through 4 sessions. In the first one, we consider what is machine learning. We think that is a software 2.0, which we will let a machine to program itself using experience, which is represented as data, to improve its performance in some task. And to do so, for the one part to do so, we would like data. We would like to believe there are some trends, patterns in the data to be discovered, and we do not have explicit expression of what to be discovered, because if we do, we will program the machine by ourselves rather than make the machine program by itself. And in the second session, we consider how to implement this epic task of let the machine program itself from experience. So for the experience part, we consider data. And by now, we all know that this is a complex notion that the data, when we talk about data, we sometimes refer to a population out there which is not directly accessible. What is accessible are observations in the format of X, Y, X, Y. And the important part of the second session is we realize that to be able to learn anything from X to Y, which is useful, we need to limit our imagination into some particular family. If we consider just whatever kind of relationship of the data, that is usually not very useful. However, we can limit our choices into a particular family, which could be useful. And I have manually implement a selection mechanism using a spreadsheet, which is a selector, but at that time, selector was me, and according to some criteria. In the third session, in the third and the fourth session, we start considering a particular model family, which is perception, and more generally, we consider the linear model family, which we learn that if we feed the columns of a data table, well, into an information processing pipeline and intuitively just give a factor to each data attribute and take the sum of it, and then we arrive at a number. And we think, so our hypothesis set is that we hypothesize that we think that we guess that all useful information about the data is summarized in this number, and we do something about this number, such as make a decision according to a threshold or something. So that makes a linear model. And in the fourth session, we get a geometric view of this model by considering both the data and the vector as the weights as two vectors in a data space. So one axis of the data space corresponds to one of the attributes. Therefore, each data can be thought as a point in a space. And by linking the origin of the space, see, this is the origin, and that point, we will have a vector, okay? And we think the linear model as taking the inner product of two vectors, and by doing so, we start understand the linear model is like to give some score at each location in the space and do something about the score, which is has been realized as like color gradient. And then we pick up a particular color and make a classification boundary there. So that is how we have arrived here. And in this and the next session, we start talking about we start talking about a new family of machine learning model, okay, which is decision trees. Which are decision trees? Okay. Today, our take-home points are simple. First, what is decision trees? How a decision tree work? on one data sample, which is very simple. You can just understand it as if else statements, and each of the statements, like if this or that, which each of the statement is applied on in the data attribute. Okay. And two, how this mechanism, how a tree applies to the data space. So in the previous point, we consider how a tree works on a particular data, and in the second part, we try to understand, instead of you do not need to take note here. I will send you another notebook. So this is just to understand. Instead of considering it's working on individual data, we consider it on data space. How such a hypothesis look like when it is applied on a data space. Okay. And this part is the important one today. Remember above here, the purpose of machine learning is to, instead of programming the machine by ourselves, we let the machine to program it by itself, but it is, well, at least cumbersome, at least not very convenient for a machine to generate if-else statements. Therefore, we will design a data structure or a computer program that realize the if-else data structure to realize this if-else rules in a conveniently formulated way, so that it could be generated by some automatic program to realize those if-else to be generated automatically. So that is our plan. And hopefully, at this point, some of you will be motivated to ask me same question as we study the linear models. How, when you manipulate the model parameters like that, how do you know which kind of parameters to choose? And this will touch the very important question, the automatically. Why? How can make the generation automatic? How let the machine to choose which data attributes to test, and what is the test condition to construct that data structure fully automatically from data. So this will motivate our discussion in the next session, and a short introduction of information theory, because that is according to the information measurement about the variable to be predicted. Okay. So this is optional, depends on our time, and we also discuss A2. Okay. That is our plan today. Okay, I got some really nice suggestions. Yes, we should break uh, from time to time to let people keep up. And I have another question about support vector machines. We will not get into the details about support vector machines. You should have already learned support vector machines in the introductory course. Of course, this is a bit mismatch. This is supposed to be more advanced subject, but the thing is like that. When I talk, if you want to learn what is a support vector machine, that is quite simple. You do not need to spend much time on that. But if you try to understand the mechanism behind that, well, that is an entirely different story. I can give you a very short review of linear model and how support vector machine is linked to that. This is relevant because this question refers to whatever we have learned. Support vector machine was originated from the linear model we have learned there. However, in that model, if you try to give one attribute to each, if you try to give one, if you try to understand that weight vector inside the data vector, the data space, well, there is a clever way to formulate, to represent, to write down the W instead of using the coordinate as you write down this X. You can write down W in a different way. How? In such a way. So basically, it is like that. Instead of using these numbers to specify W, okay, I don't do this because when the dimension of the data is very high, I need a lot of numbers to do so. However, I will save my effort by put W among which it is to be interacted. Like you have x1 here, maybe x2 here, and you might find, okay, how about let's use 0.25 x1 plus maybe 0.3 x2, and so you get something here, and you combine these two. Okay, let's use this as W in this way. Okay, adopting this view, another then you think to do the inner product of W with any X, that would be to do inner product of your data samples with any X. Then you will find that it would be a good idea, very good idea, to use simple models, which is linked to what we will discuss today here. Simple models is better than complex models, and which is also the main theme of machine learning everywhere. We limit our imagination. We limit the complexity we would like to consider. Okay, we adopt this. I think I have some issue. Doesn't matter. We adopt this and we limit our choices so much so that we want the vast majority of those A's to be zero. And W is to be constructed using a few number of samples. Okay, in such a construction, these coefficients is seen as the combination of a very few number of data samples, and those data samples would be defining the classification boundary. Well, that is a bit hairy math. inside, but you just need to believe me. So those ones, rather than the one that is non-defining ones, the non-defining ones, it can be thought as inside the far away from the frontier, but those ones are close to the frontier, so that the classical boundary is just a path through this. That is a supportive vector machine. It's a kind of one family member derived from the linear ones. Okay. And well, this is just yet another family of model. By a family of model, we think as a different way of limiting our imagination about the relationship of x and y. You can see that I have just introduced yet a very different way of considering this relationship, and today we just do yet another way of considering that. Okay, for the first one, it's very, very simple. We do not spend much time here. It's just like given an x, this is a decision tree. So like think of x table, and do not let yourself be confused by the indexes. Sometimes I'm not very good at distinguishing them when talk, but you should clarify that in the context. See, I'm now talking about xi, which means the ith sample, and I may consider the first attribute of xi, but sometimes you just call that x1 here, so don't be confused. When talk about x1, which usually means the first attribute of a sample, okay? So it just work like that. If xi0 is maybe less than 5.5, then return prediction to be for I to be positive 1. So I will predict that to be positive 1. Let me change this a little bit. Okay. So this does not necessarily stop here. We can build more. Let me put an if here. We can build more complicated rules, such as otherwise. We do not just return negative 1. No, we can make it more complicated. We then do some judge about and then we can do things like that. So that is how a decision tree internally works. And it is called a tree for this reason, such as when our sample xi arrives, then here it will take the first attribute to compare with C, and it has branches Yes or no? If yes, then do something. If no, maybe we can then do something. So the information flow is corresponding to such a tree like structure. The logic is like this, could be represented as a tree. Okay, so at this point, this is just intuitive, not very super fun. Let's check something out more more exciting. How would that look like on a data space like here? Okay. This is the visualization. And if you recall that, what? I don't know, maybe it's, yeah, is that working? Yeah. So if you recall that how a linear model does on the data space, it is like I will give a color at each point, and then I do something about the color, get a classification. But here you do not have that score anymore, right? That score, we do not have a score. We directly make our decisions. Why it is called decision tree, for a reason. So I adjust the visualization part a little bit to facilitate the picture. But basically, it shows how a model works similarly. So let us try to invent some of the if else classification rules and see how it works. First, let's have a look at the structure. I just consider a table of X, and then the shape means this and this. Okay, this is shape 0, which is just the number of rows. So I loop through each row and consider this xi. So now we consider our xi. Okay. Well, then I will do a prediction. So here is I allocated an array for the prediction. I'm just going to do a prediction here. Okay. This is my classification. And I'm first doing the brain dead one, which is not very interesting at all. I didn't look at that and just returned -1 and see how that works or how that does not work. Not very interesting. Well, now let us start building something here, okay? So as we have discussed, let's do an if else thing. By the way, for people who have got the token into the code demo, You can, if you'd like, to join me here. It's okay, as long as the virtual machine keep running. If we blow it up, okay, I will move to Colab. Let's do something. Consider this, well, this is not a very nice visualization. I can read it here. It's 5.5 here. So I'm trying to do a classification here. Maybe I use 5.51, maybe no, 5.49, and I classify that part, the right hand side, as a positive one. Okay, so let's do that. Sure, this isn't very difficult to understand, right? So let's go. You can see we have successfully make something. Okay, yeah. Then how about you? It's obviously this classification is not perfect. For example, we have misclassified samples here, right? So how about let's make a second rule, maybe put it here. Like we have already know that the yellow one represent positive. Okay, let's make a rule here about the xi second attribute. Let's do this second attribute. So otherwise, for the left hand side, I'm in front of camera. I don't know on your screen if this is the left hand side. Okay. Anyway, I'm pointing here. Otherwise, if xi for the second attribute here, second attribute refers to this axis, and let's find a number to decide. Maybe 2.8. Let's try this. Okay. In this case, if it is below 2.8, we return positive 1, otherwise negative 1. And now let's see how it works. Oh, I think I have made a mistake. Which mistake? I should determine on the left-hand side, but no, I mistakenly put this branch on the right-hand side. Okay, so I just need to copy this up and put this down. So again, right? I have noticed that some people have already joined. If you have already joined, please come here. Anyone who is who is collaborating with me in the notebook, come here. Yeah, good. Ahmed, thank you very much for coming. Okay. You guys agree with one each other. Can you please do something about this side, and let's make a line cut here. How about this? Can someone of you do this? Yeah, just try. You won't mess things up. It's okay. Oh, yeah, Ahmed, please come here. Yeah, and let us make another rule to cut here. Oh, you invent some rules here. Okay, let's see how it works. Okay, Ahmed has moved our first cut from here to here. Okay, that guy seems like fun. Okay, that does not work, and he just fled the stage. Okay, fine, it's okay. But anyway, oh, you come back. Good, good. Yeah, yeah. Let's do a if else here, maybe. Go ahead, go ahead. You can do this. I let me write a template like that. If xi, yeah, and here we also consider this attribute, and I can read the number for you, maybe 3.5. Okay, try to maybe compare that with 3.5. Maybe not equals to. You need to compare it with, such as, yeah, good. You need a column. This is a semicolon, make it a column. So for students who are not here with me, you can, Ahmed, you go ahead on your computer. I will change a little bit here. You can open this link in the online materials and make a local copy. Make a local copy, and you will be free to play with us together. Okay. Okay, that is a good choice. Well, you know, we now have 3 colors. Why? Because now we consider when that is greater than 3.5, then we give it a positive 1. And what you have to do is to give the else branch a number. Otherwise, the number keeps 0. And now you have 3 numbers, positive 1, negative 1, and 0. And 0 isn't a class we will consider here. So yeah, I can help you to do this here. Yeah, okay, you can do this. Fine. Uh-oh. So how about flip it? Rather than use greater than, let's use less than. So yeah, that's maybe, yeah. Okay, let's try. Fine, we are getting there. Maybe we move the first judgment back to this part, then it will be done. Okay. So, but sure, play with that as much as you would like. Our point has been made. When it is applied to the data space, yeah, good. That is good. A classification, sorry, a decision tree works in such a way it cuts the space along the axis of that space. Okay, it is not like a linear model. You can cut a slanted boundary. Well, in this case, all the cutting lines must be parallel to the space axis. Sorry, I sometimes I just do that too quick. Let's do that slowly. The cutting lines of the decision tree classification boundary is parallel to the axis of the space, and the axis of the data space, each one of them represent one particular data attribute. the columns of the table. Okay. We can extend the discussion from here so that it is not difficult to imagine this kind of judgment does not depend on too much on the numerical characteristics, the numerical properties of those attributes. Okay, so it does not require those attributes to be numbers at all. The judgment can be happily done in such a way that if this attribute is male or female, smoker or non-smoker, married or single or divorced, well, it can be done in a multiple choice way, right? So decision tree has such a stop messing things up. Decision trees has such a nice attribute that a nice nature that it works with all kinds of data types. Sometimes it even works when some attribute is missing. When I'm trying to make a decision, well, and that attribute isn't available, well, I still have a way forward. Sure. So that is how decision tree works. And on individual data, how it works on individual data and on the data space. Let's do a polling, see if we are good to go. Okay, I think we have made the point. So the next natural step, well, it's I think the focus today. We now understand that by making very simple if and else rules, we can draw interesting pictures on the data space and implement our goal of making decisions. And the next natural question is how to implement that automatically. Let the computer to do that rather than we as a programmer, we as a programmer to program to explicitly represent those rules one by one. Sure. So that is our goal, to automate the procedure. To do so, let's design a clever data structure to implement this. Okay. Well, let's consider each node at which the decision is made. Okay. I'm start writing a data structure for that. Okay. So consider such a node. I will, because that node has a behavior, both the behavior and information. Therefore, I will create a template for that object. So which means this is a class. Well, I'm starting from the end. I consider how that object is used, how that works, what makes it tick. So imagine that being alive, and then we look back, we backtrace what is needed inside it. So this is a way to do the design. Okay, so I imagine to use it to do predict. For simplicity, I don't deal with a data table, because otherwise you need to consider, okay, I'm dealing with an array, stuff like that. Let's just think about it is given a particular sample of the data. So this is to be made in the first place. I define that to be a predict function for that. And in object template, the method usually always have a first, argument. This is called an argument. The first input as a self. So this refers to myself, because remember, we are doing a template of objects to describe the behavior of each member in the object class. So we need something to refer to individual ones. So in each individual one will have a parameter of self to refer to itself. Okay, so this is to be made clear. This is a Python thing. And xi, let's just call that xi, and return the predict. Okay, and let the predict maybe to be null first. Following our previous example, let's just make things alive first, without considering too much how that works. Okay, so do a branded one. Okay, and I copy this classifier here. You can see I create such an object, and here I will use that object to do all the prediction. So this is simply a ramper that dispatch the classification, task to our tree node, and then does nothing. Okay, and let us see how that works. What? I have some issue. Okay. Not very interesting at all. Okay. Yeah. And now let's try to implement that here. For it to be really working, okay, I think the first thing, we all must agree that there are only two possibilities at each node. One, we are ready to make a decision. Two, we are not ready to make a decision. It sounds like a tautology, but look, that distinguishes what is at the end of the process and what is in the inner part of the process. If it is at the end, we have a decision ready to return. Otherwise, no, we need to do something more. Okay, let's this. This is to prepare some information inside self, okay? I just write things down in a different way, okay? So the result shouldn't change, also uninteresting. Sure. What we need to do is to create something that branches. Okay, so therefore, I want to do something like that. Decision is not ready here. Check. What is the number? 5.49. Okay. So this is what to be implemented. Therefore, we will give possibility of decision not ready. Okay, and if self dot decision is not, no, we do this. And now we don't do this. What we need to do, we take the value, we check the value of what? We don't put a 0 here. What we want is this is determined by the node. This belongs to the internal information of the node. What we do, we can just write this down in plain English, but of course this is maybe not a very technical variable name. So I put it now here because we haven't constructed it, but it should be some integer number, or we can put something like here. It's invalid, but it looks like an integer anyway. Okay, so okay. Threshold. Okay, then the next step is interesting. This is what makes things very interesting. Then okay, that is what we are thinking about. Okay, so we then just return whatever would be returned by self dot children left hand side. Okay, less than predict our xi. Otherwise, greater than. So this curly bracket represent a dictionary, which is just a map of objects. I have an index here, and with this index, I have this. So basically, you will have less than and greater than here, right? Okay, to implement this, we need to do some adjustment of our tree model. Okay, so we create another tree model. We create yet another one, left and right. The left-hand side has a decision to be -1, and the right-hand side has also a decision to be +1. And the middle one, remember that it does not have a decision. What it does have is a link to the left-hand and the right-hand side. Okay. We need to give it something to link. So first, attribute to check, that is the zeros attribute to check here. And the threshold is 5.5, maybe for 9. And the children less than, make it to be the left-hand side, this guy here. Sorry. Okay, we linked everything up. And note that we didn't change this at all. We just changed the data structure here. So this is our goal. Our goal is to implement those if-else in a more complicated, but has a complicated way, which has the potential to be automated. So, right. Okay, let's see the potential we have acquired here. See, instead of maybe consider the horizontal card, we consider the vertical card here. We just change this here and change this here and see what we have got. So it's totally different. Well, maybe following the previous example, we might not want to the left-hand side to make a decision directly. So what do? We do the same to the left-hand side. We remove its decision, no decision here. Okay. Then we create two tree attribute following the left-hand side. We call that L1 and L2 maybe. Okay, and for L1 and L2, they should have decisions. Okay, maybe L1 should have decisions. L2 decisions. Okay, And then we give the left-hand side, this L, some attribute to check. 1. Okay, now we have done a branch here, and this branch checks this axis. Okay, let's see how that works. Let's see. Okay, we can see that now instead of writing down the if-else statement in a program, now we can convert that into creating a data structure to represent the logic flow in the decision tree. You can practice that by yourself back home and play with it. This is a really interesting thing to do. So let's pause for a while and see how that goes with everybody. I got a few people yelling, I need help. If you need help, you can just speak up, ask questions, because now we have very few people need help. You can just ask me. I got a question about how to get access to this notebook. I think in the announcement of week 3 or week 4, week 3, I have yelled for volunteers to join the notebook. You can anyway. You can check that announcement, but here is you can register a CoCoC account. If you have the CoCoC account, I can put a token here so that you can join. Let me find the token. Oh, I have a lot of people in here. I have copied the token and if you get the account, I have put the token in the chat box. But it's okay. You can just use this notebook. Basically, the content is essentially the same, very same. By using this, you just do that locally. You didn't collaborate with me alive. But anyway, we cannot support too many people in this notebook. Otherwise, the computer will just stop working. Okay, I'm very happy. Many people, I think many people are following. Well, it is very natural at this step to ask, okay, you have manually built up those rules, right? How could you build these rules automatically? I think that is the essential of machine learning stuff, right? Well, following our thought of putting our feet in the boots of those decision-making those guys, we try to consider, and if we are one nose here, what we should do. Should we return a decision, which means like we are creating those structure, and now we have arrived at a node. We then make we have a higher level decision to make. Should we just return a prediction here, decision done, or we need to look into the situation more and split the situation into 2 or 3 or multiple ways? Okay, so here in the constructor's point of view, we need to think about what is in our hands right now. I'd like to invite you to consider the situation in an analogous way. Like, say, if you are a fishman or a fishwoman, now this is your net. And we have some fish or shrimp, whatever, creatures. So the situation is like, I use this analogy to emphasize that please now focus on the target value part of the data. So let us view our data samples more focused on the species of the creature. We want maybe certain kind of fish. We want to distinguish certain kind of samples. We concentrate on this part first. Okay, that helps. This viewpoint helps you follow the following discussion. Otherwise, it gets confused very quickly. Okay, focus on the target value we want to predict. Well, then, now then consider the attribute of the creatures. Now consider the attribute of the creatures. Link different columns of creatures, such as the length of the fish, the weight of the fish, whatever here. And what we want to do is to make our net with some attributes, such as we can make maybe the size of the net, or maybe we can operating at some depths. We do not just throw the net in and try to catch everything. We might use some maneuver so that we only catch fishes at a certain depth of the water. Therefore, for fishes that happily maybe live here, they won't get caught. Okay. Or maybe we can use some certain way of, well, whatever, I don't know, because I don't the fishing, but you get the point. We can select, we can do the capture selectively. Therefore, to select some certain classes. If we do that in a different way, we select different classes. So try to view that. And the previous question, when I'm building a node here, whether I return my decision here or I need to do more splitting. This question corresponding to, now I have my net here. Okay, I have designed my fishing strategy here. Whether more measures to be made so that the species in my catch is more focused. Okay, or I need more measures to do. Can I just take my net out of the water and take whatever in the net? Or I need to do more measures, like do another maneuver, do something, adjust the catch, stuff like that. Okay, whether the selection is, more selection is needed. I hope that motivates the situation enough. Okay, so if I successfully talk you into this story, you could understand that, you could agree, you might agree that the next important thing is to measure the purity of the population in my net. Okay. If I'm sure all I have at this situation, all the population or 99% of the population belongs to one species, then some decision could be made. I catch it, I free it, okay? I recognize that as something. Recall here, I cut here, then I cut here, cut here, then cut here. Okay, I think this part is pure enough. There are some errors, but okay, I'm cool with that. Decision to be made right now for this, sure. If I'm not cool with that, okay, maybe I cut here again, and then I cut here again. For this part and this part, both have very pure population. Okay. So we need some mathematical measurement about how pure it is. For two reasons. For one reason, we could use that to determine, okay, no cut is needed anymore, stop here. Secondly, we can decide how to cut so that each part get its purity improved. So this is the question we are going to address here. There are a lot of ways to do that, such as motivated from economics. We can do like a Gini index thing, like of measuring the purity. We can directly count samples belongs to different classes, whatever. But in this subject, in this session and the next, I will try to motivate everybody into a particular way of measuring the purity that is from the information theory. The reason not because information theory is the only way or the best way to create decision trees. That is because information theory is such a useful way of thinking in a lot of branches, in a lot of sub area machine learning, and artificial intelligence. By having knowledge of that, it opens door not to decision trees, but a lot of different data models and algorithms. So let's study that. I hope, but this is a really abstract piece of knowledge. So I think we need to get well motivated. I hope the story serves the purpose. Okay. So to measure the purity of a population, we convert it to information theory, and it's converted in such a way you can consider if you have a jar, a net or jar or something, they are the same thing, a collection of things. I use that a jar to serve my story here. See, if you are taking, well, you are a very strange creature. Some balls in the jar, and both you and Alice, see, you are Bob, and here is Alice. Alice looking away. Both of you know that you have the jar, and the jar has a mixed collection of colors, different colored balls. Well, you take the sample of the jar, and you want to tell Alice about the color of the ball. Okay. However, for example, you have a really poor communication channel that either is very noisy, bad, or it charges you a lot to communicate. So you want to talk as little as possible. Or alternatively, if you can talk certain amount, you want to repeat your message as many times as possible. Either way, you want to keep your message succinct. You want to keep your message as short as possible. So with you can spend less money, or with the same money, you can repeat the question many times. Repeat the message many times. Yeah. So you want to design some clever communication protocol to communicate the message of the color of the ball between you and Alice. Why this is linked to the question of how pure the population inside the jar. Okay, it works in this way. Think that the purity is 100%. I got the question, does purity refer to the entropy? Yes, purity here, I'm using entropy to define purity, but purity is more generic. You can use other ways to define that, but now I'm introducing entropy. Yes. So think that the purity is 100%, which means uncertainty is 0%. For example, now both you and Alice knows everything is green. Then how many bits to communicate to let Alice know the color. 0. You do not need to see anything. The communication is infinitely efficient because there's no uncertainty, nothing to be communicated, right? On the other hand, if it's very uncertain, for example, when you have 2 colors to talk, and these 2 colors take a 50-50, split, then how many bits to communicate the color? 1, right? This is the maximum uncertainty in this situation. Okay. So, on the other hand, which is more complicated, I won't get into the detailed discussion here. If the situation is mixed, for example, you have 80% of yellow and 20% of red, then how many bits? The bits is greater than 0 and less than 1. Why? Because in this situation, you probably won't need to communicate the outcome of the colors one by one. You could, on the other hand, cleverly decide different ways, different events, such as this is an event, and this is another event. So you can give different length of code for each of those events, and therefore see some of the communication. The discussion is easier when we consider this way. Instead of communicate 2 colors, we consider more colors. Say maybe 4 colors. Okay. Then how many bits is needed to distinguish 4 colors? Well, that would be, you need 1 bit to distinguish 2 colors. Okay. Ask that another way. Sorry, maybe that makes things easier. If you have 2 bits, how many situations? You do not need to necessarily consider that as colors. It could be situation. The situation could be designed in such a way of mixed numbers of different colors. So consider that in an abstract way. Do not need to link that to be specific colors or fish species or different combination of colors. Well, we just consider that as different possible outcomes. So now it's time to start think more abstractly. Well, if we have 2 bits, how many situations we can distinguish? Okay, we can use 1 bit to split the situation into 2 parts, and use then in each of the part that becomes a two-way classification two-way dichotomy situation, which backs to here. Okay, so we have 4 situations to distinguish. And if we have 3 bits, well, we follow the same thing. We can use 1 bit to distinguish situations here, and then we copy and paste. We can have another copy of the situation, not the exact copy, but different things. Then each part will be will be in a similar situation as using 2 bits to distinguish 4 situations. Okay, so this will motivate our definition of entropy. The entropy refers to the minimum length of the code to describe an uncertainty system. That would be the weighted sum of using different lengths of code to describe possible outcomes of the system. So the number of bits would be proportional to log of the number of situations. Okay, and the number of situations would be 1 over probability of this situation. And in the entropy definition, we take the sum of that. Well, I think we will discuss more about that. We just need a motivation into this discussion, and we will do the more detailed discussion in the next lecture for that. Okay. Sure. Let's have a look at our assignment 2. You can see assignment 2 here. Okay, the specification and the rubrics are listed down here. And we have provided an example that explains explains the requirement in the specification and something in the rubrics. So, for example, we said you need a clearly defined title. You need to you do not need a cover page. You need some format of the link. There are some requirements. There are some requirements to discuss the implementation and a clear link to your code. Requirements like that. Please take some time to read the example, and I will have QA time in the next lecture to let you ask me questions about this. Okay, what I'm going to talk here is emphasize here some frequently asked questions. First, let me check. Okay, we do not check similarity in your code. We provide explicit detailed guidelines or tutorials to help students to implement these algorithms. You can review our code. You reuse our code. We do not check duplication in the code. We mainly mark your report. We will mark your understanding of your code. Okay? First thing. Second, it is allowed to use toy data because the focus in this subject is the machine learning model itself. The application to data is a necessary step, but you can use any kind of data to demonstrate that part. Okay, but if you choose to use some data that is not readily available from the built-in libraries. For example, you want to download the data from, for example, Kaggle or somewhere else. Please prepare your data in the notebook, in the online notebook. For example, you have code snippets, you can type down. It's not difficult, although it's technical, but the many online platforms just give you template to do that, like download files or import data. Then very easy. You can do the you can use a file that's stored in somewhere on the internet. Okay, you can do this, but please, when we mark your assignment, we because of the limit of manpower, we cannot just manually prepare data to test your code. We will just go to the menu and type run all and see the result. So it is your responsibility to prepare the data if you use something that is not in the scikit-learn library or some built-in data set. Okay, prepare your data. And if you prepare your data, please do remember one thing. It is not only limited to data. Test the link, test this link using an anonymous or third-party login. Sometimes people send us a link that is shared only to him or herself. We cannot test the link this way, and you lose marks for that. And basically, you lose all the marks for the implementation part because we cannot access that. That is the situation. Please do avoid. Okay, you can easily do a Ninja login, so such as the private browsing, or in Chrome is Ninja mode, whatever. Therefore, you do not log into your own account and use a third-party account. That is to simulate what a marker will encounter when mark your assignment. Keep that in mind, please. Okay. What's more? Well, from scratch. I'll give you example to show this point. By scratch, we mean the basic elements of the algorithm must be implemented by from scratch. However, for the data preparation, test, evaluation, these auxiliary functions, yes, you can use whatever is convenient for you. Okay. Here is an example, a good example, of course. I won't show poor examples, maybe. So look, oh, it is the implementation of decision tree. And here is a project link. That link contains both a clickable link, which makes our life very easy, and a plain text link. This is because some of the systems will strip the embedded URL from the PDF file. If you just give us a link that can only be clicked when that URL has been removed, then you end up with no link at all. So please put a plain text link that we can copy and paste into address box directly, okay? But this way, we can click it anyway. So look, when I click that, although that code, that notebook belongs to the student, but I can access that, okay? When we mark it, we just click Run All. So all the data is prepared inside the notebook. The implementation is detailed. You can see whatever is needed in a tree node to implement the decision tree with reasonably commented code. Okay. Well, so everything is explicitly listed here, and in the report, the data structure is clearly mentioned, discussed, and the important computation is discussed. For example, like here is what we have introduced in this subject, and how this is mapped to a computer program, and issues about the computation complexity, and the dealing with different types of attributes, such as the discrete attribute and the continuous attributes are all discussed. So this is a very well done report. And you will get feedbacks like that. We will mark internally in this way. So like I cannot upload this PDF file. I can, if you want to review, you need to review the video recording of this lecture. This belongs to the student. I don't have the right to put that on the Canvas side. But I do have another PDF file that is a template from which this has been created. Okay, so if you have the properly titled, you get this mark. The link is working. The implementation is good. Okay, and we check correctness, readability, and something maybe actually implemented. Okay, for the report, there comes different parts. You have 10% of the marks goes to introduction. The major part goes to the algorithm. Then we check your understanding of the algorithm, and it is very convenient if you make a clear link in the discussion and the algorithm. Therefore, when we mark it, we find some issue to feedback to you. We can just write, okay, please look here. You may have some issue. Perhaps you can do this or that, stuff like that. Okay, and some part goes to the evaluation. And please be noted that do not write an experiment report. The report is about the algorithm, not about the experiment. Okay, don't just paste large number of computer generated visualization to show that you have a very sophisticated output. No, that is not necessary. Just evaluate sufficiently to demonstrate, okay, I have a code that is working fine. Okay, some reflection in the conclusion. I show you two examples that are bad. Where is that? Where is my? There is a borderline, very dangerous borderline of repetition. Okay, we do check repetition example. Okay, so look into this report. The student have a large repetition of text copied somewhere. It's really like a patched work. This is borderline. I didn't find a whole sentence of repetition, so I didn't give it 0 mark or report misconduct anything. But this won't get good mark anyway. We all understand this behavior. Sometimes it copies from but quoted like this, but it just used too many that's quoted to compose his report. This is not a good way of discuss. It does not show your understanding of your implementation. If you really implement that by yourself, you have a lot to say about it. Don't just copy and quote from other text. Okay. And here is a really bad example of repetition. If we encountered such report, it will receive 0 mark, and misconduct will be reported like this. There is a large text body copied from Wikipedia and other online materials. That is unacceptable. Sometimes people argue that, look, you have limited ways of referring to technical notions. Yes, but you always have the option of describing those notions using your own language, your own words. Okay, don't do repetition like that. This is really bad. Okay, we need to be a little bit quick about the quizzes. How do I exit student view? Preview. Okay. The first question is remind us the main theme of machine learning. Basically, it says when the performance is similar, simpler models is better than more complicated models. So, which means this is correct. To achieve the same classification on the training dataset, a tree of less questions is more preferable than one with more questions. If you ask less questions about the data attribute, where is my? If you ask less questions about data attributes, which means you do less split, and the tree is simpler, the model is simpler, it tends to be more generalizable. Okay. The second one is wrong. More complex trees tend to be more accurate on the test data. No, it could get overfit and get more generalization errors. This one is asking about the purity measure. Okay, for an experiment of two possible outcomes, an observation from this more uncertainty system contains more information than this of a more certain system. This is true. Think that in this way. If you are sitting in an exam and you want to cheat, okay, you have only one chance of doing that cheat. Well, we have the chance. But you have two questions. You don't know the answer. However, for one question, you are really have no idea about that. You don't know what to choose, A or B. And for the other questions, you are maybe 90% sure that the answer is B. Then on which question you will use your one chance of cheating to know the answer? Probably the one that you are more uncertain, because you gain more about that. That means the information in this system, the observation of the outcome of this system contains more information. Look, information is really an abstract concept. We need to view that using so many different ways to make it more concrete, okay? So the first one is true. The second one basically says, if the situation is certain, then an observation is there is no information. It's like, I do not need to wake up early and observe from which direction the sun will rise tomorrow. That is no information, because that is certain. I know certainly the sun rises from the east, not the west. Okay, so both statements are true. Question 3, basically it says, it just says there are two types of nodes, and the nodes at the leaf at the end points of the tree returns a prediction of the target, and all other the other three is are to remind us misunderstandings of the tree. Let's maybe have a look at them. One is the number of the nodes is the same number of the training samples. No, the nodes are caring about the data attributes. When we do the selection measures, we do not care about how many fishes, how many pieces, or I don't know how to refer to the number of fishes, okay? Fishes or say creatures in the net. We care, the measures, number of measures cares about the different attributes to distinguish one creature from the other. The particular number is not relevant here. Second, one tree has the same number of nodes as number of attributes. Well, that isn't true. We could, when the situation is really simple, we could make the decision with less numbers of nodes, such as when we just cut the two-dimensional data one time, then we have left and the right. We have one cut, but we have two attributes. On the other hand, when things get more complicated, we might need to cut more times the number of attributes. Like we cut this way, we cut this way, and we cut this way again. Third, a decision tree must be deployed with the training samples. No. When a tree has been made, the training samples can be thrown away. Okay, and then we only work with the data model. So I submit the quiz. Okay, summarize. First, simple trees, less questions is good. Second, both are true, more certain, less information of an observation. Third, the endpoints of the tree returns decisions. The tree nodes does not number of nodes does not connected to the number of data samples, and it could be uncertain how many nodes in the tree and compared to the number of attributes in the data. Okay, and a tree does not need the training samples to work. What I mean, after being constructed, it does not need the training samples to work. Okay. Okay, to summarize today, we consider how a tree works on individual samples. We consider how that mechanism applied to the data space, which gives us this nice card. Also, we consider how to translate this if-else into a data structure that support the construction of the if-else in a more formulated way, so that in future we will consider the tree construction algorithm to automatically create tree nodes and link them together, therefore to automatically form such if-else classification rules to fit the data. Okay, and we look into a little bit into the future, the next time discussion about how to construct a tree. How the first step is to be able to measure at one node how pure my population is. By how pure, I don't mean how pure the data attribute is. I mean how pure the target value is. Because when the target value, when regarding the target value, we reached a consensus here, then we can just return that value without looking at X anymore. On the other hand, if we do not have a consensus, we might want to use the X part to do more split so that the purity get improved in both parts. So that is what we need to learn today. We also discussed a little bit about assignment 2. There is only one reminder before everyone goes. I need to talk to you. We have a rule of applying extension of the deadline for assignment 2 and 3. We do not accept application of a deadline in the last minute. We don't do that. I have put a booking spreadsheet online, which I will announce, the link I will announce in the announcement today. There are different stages you can apply the extension. If you expect you will be delayed regularly, please apply before 2 weeks of the deadline. From 2 weeks of the deadline, before 3 days before the deadline, this period, we only accept urgent application, which you need document support. In the last 3 days before the deadline, we do not accept application of extension anymore. If you have something happened during that period, we accept appeal that we can mark your submission using maybe a different criteria to give you more marks. But we do not accept application of extension in the last 3 days. The assignment is designed for 4 weeks of work. We don't accept extension in the last 3 days. Okay, so please keep this in mind. I will announce that later today. So okay, thank you for joining us, and I'm staying here for another half an hour. I sip a cup of coffee. If you have questions, you can type that into the chat box. Yes, how many days to be extended? You can read in the document. They will be clearly stated there. You can apply, I think, 2 weeks. I will write this explicitly today. And the example won't be posted, but the example the example template will be posted. Also, we have yes, I will allow people to check similarity. I have set up the assignment in this way. So look, that is another reason to do things earlier than later. When you submit that, you can see the similarity report immediately. Okay, so there is really no reason that you end up with a report with a high similarity. That is nonsense.
Chen, what is the similarity rate that is allowed?
Well, I don't give you a hard line. When, for example, it is very easy to get a similarity of 30%, but still being a very good report. For example, when you code your own code, and I said the similarity in the code won't be counted, we will look into how the similarity is raised. For example. Where is that? Okay. Like this part is definitely similarity. We won't tolerate. And let me see. Like this part in your reference, of course, when you refer to something that must be similar to something else, we won't count this part. So, but Turnitin won't let us to, okay, remove this part and then do a calculation again. It just automatically give you a number. Therefore, we don't use that number in a very strict way. We will do that. We will evaluate case by case.
Thank you.
Paper or something, but is it safe to assume you want us sort of to stay away from that and to make our own, because we are just showing our understanding of the model, not what some not from something from a report, correct?
Sorry, I think your voice is a bit low. Can you repeat it slowly, or you move maybe closer to your microphone?
Yeah, I was just saying, in relation to this report, for example, they make a lot of references to whatever that reference, but is it safe to say, no, sorry, the bad one?
Yeah. Because someone else asked me to show this again.
Okay. You want us to only pretty much explain our understanding of the model, not something from a paper or something, correct?
Basically, short answer, yes. You can read the paper and understand the paper and retell the story by yourself. It's not that difficult when you really understand a thing and retell the thing. And in this way, it's very hard to be repetitive with someone else.
Okay.
Yeah, like see, you can read like this guy is really understand what is going on and describes what things that has been done by himself. So it reads very natural. It doesn't like you just do a patchwork by using a lot of different sources of information.
Yep.
Yeah. Like the second step is doing stuff like that, stuff like that, stuff like that. I think I really like when, yes, it's here. We compute the information gain, which we will discuss in the next lecture. How to compute that? It split into two situations. I like that part very much because that isn't covered in this class. I mentioned you can do both type, but I didn't explicitly implement a tree that can handle two types. But this guy just does that by himself. So if it's numerical type, if it's a categorical type, and which means not numerical. So look, that really like it. He is describing what he is done and try to do some reflection about it. Okay. Submission multiple times. Let's see. Yes, I think you can. Oh yeah, thank you, Anton, for answering that.
Okay, I have one question. Can you hear me?
Yeah, I can. Please.
Okay. So is it mandatory to use words like Microsoft Words, or can I use LaTeX with something else? Because I prefer LaTeX.
Yeah. I prefer LaTeX as well. You can use LaTeX.
Great.
Yeah. It's I think the submission format is PDF. So whatever you use, you convert to PDF and then submit that.
I know, but some subjects doesn't they don't allow like LaTeX generated PDF files. So I just asking.
Oh really? Yeah, but if you ask me this, I feel a bit awkward. You'd better to try early. I'm not sure if these guys reject LaTeX
No, I
file.
mean like turn it in. I mean like for example, Canvas is fine, but some subject coordinators specify that you should not use LaTeX with something else.
Oh, okay.
So that's
okay.
the reason why I mentioned about it.
Okay. No, there is no such. As long as the Canvas accepts that, you are fine. You are good.
Thank you.
Okay. Well, this is a good question. Is there a required file name or format? Wow, you should have asked me earlier. Then I would put the requirement of file name because that will make life easier for us. But now it's too late. There's no required file name. But if you would like to make the life easier for us, you can put your name, ID, 31005, the subject number, and assignment number A2 there. And the file format is better to be, not better to, the file format is required to be PDF. And the file format is, the format requirement is given in the template PDF there. Okay, I cancel. So this gives that. Okay. Any further questions? Please be aware that you can always join in 20 minutes when Anchen will host a session helping mainly about coding. If you have more detailed queries about coding, you can let him help. Well, good. That's a good question. The subject line states there is about 1,000 word limit. No, that is not a word limit. It's an approximation, because we always receive questions about how long the report is. The 100 word is about the length. I think we approximate. You can clearly state every aspect of address every requirement of the assignment. There is no upper limit of that, and on the other hand, there is either no lower limit. This is a flexible guideline. It's not a limit. You do it according to your own situation. Anton will record the session. Where's the link? The link is here. You can always find all the links here in the modules. There are, well, I don't know how to pin those pages in the front page. This is super useful. Schedule. You have all the links here. And I think Anchen's one is here. Fridays. This one. And there's another one. Online materials. We will put YouTube and download link, YouTube and download link here. When we have a notebook link, we'll also put it here. Okay, Anchen, can you do this? Maybe next time we also do this. I think we did. Do we have this one? No, we didn't have this one before. Anchen, when you record that, you can add a line here similarly as my one, but with a statement like consultation 3 or 2, and put a draft download here with the password.
Yes, no problem. If necessary and enough content about assignment or coding section, I will put that link.
Okay. So, okay, maybe we'll wrap up here. Thank you very much for coming, and have a nice weekend. Bye-bye.